So what group wants to share their prediction for number 4 when you stack 16 cups? And remember, we're all going to have different data, so we're just looking at more of the procedure than the actual number. So understand that you had different sizes, so some people are going to have different data than you. Okay? But what was your prediction for 16 cups? Mania. Tell us what your first cup was. Your first cup was how big? What was the height of your first cup that you measured? 8.5 centimeters tall? Okay, so that was your first cup. Did it have a constant rate of change, just out of curiosity? What was it? So the table you used had a... So it went up 1.5. So you're saying the second cup went up to 10, right? And so on and so forth. So they had a constant rate of 1.5 centimeters. Okay? Now again, users may be different. I think we had someone who went up 2s, right, if he did 1. Some didn't go up at the same rate, right? Some did, and some was all over the place. Remember we talked about non-constant rate of change? Okay. All right, so how'd you guys get to 16 from there? 8 times 2? So you're saying 16 cups are 16 centimeters tall? Remember, if each cup is 8.5 centimeters, how tall is that stack going to be when we get to 16? All right, that's okay. Hey, that's all right. Again, we're trying to develop a method of thinking. Because one thing we don't want to do you want to sit there and go, well, at 3 cups, it's 11.5, and at 4 cups, it's 13, and at 5 cups, it's 14.5, and it's... I mean, you're going to be sitting there going, especially when you do the 50, you're going to be writing down through here, flip the page over, and at 31 cups, it's 32 cups, and you're just going to be staring into, your eyes going to be this big, staring out into space, right? So what kind of shortcut did you come up with to kind of help solve this quicker but efficiently too?
I made an equation. I did 16 times constant rate of change equals height.
Okay, so you took the cups that you wanted by the constant rate of change. So you did 16 times 1.5?
Well, I did 6 answers, so my constant rate of change was 2, but yeah.
Okay, but you multiplied your constant rate of change times the number of cups that you wanted to.
Yeah.
So 16 times 1.5 is 24? Someone check me on that calculator? Is that 24? Okay, so all right, so let's think about this method for a minute. I'm going to kind of stretch this out a little bit. So do we get to 24? Let's see. We go 17.5, and then 19, and then 20.5, and then 22, and then 23.5. So at 12 cups, technically we're 25 centimeters high. How many people did the same thing for 50? Took your constant rate of change and multiplied by 50. Okay. So what we're going to do is we're actually going to come up with an equation. This is kind of one you've probably never seen quite like this before because there's a special factor here. All right, and I can explain to you why you were off here. Oh, I thought he hit like the wall or something. I'm like, what the? There's no grass over by here. Cut of cement. We just got that live, by the way. Okay. So remember, a prediction is what? Is a prediction accurate? No. I think was it this class I talked to you yesterday about the guy who predicted the end of the world in 2012? Was he accurate? Well, no, because it's 2016 and we're still here. So he's off. So a prediction is like an estimate, right? It's an approximation. So depending on what you did in 4 and 5, but the equation is one thing. So, all right. So with the equation, right? Remember this? Right? Equation of a line, right? You guys learned that in 7th grade. So B is our what? Our beginning, our starting point, right? So let's think about this for a minute. With our cups, All right, I'm just going to use Minea's data because she chimed in. So your starting point was what? Your first cup was your starting point, right? Which was 8.5. So that was the height of her first cup. So technically, when we had 0 cups, did we increase from 0 to 1 cups, increased 1.5 constant rate of change? No. So we didn't start increasing the height till we added what? Huh? The second cup, right? So our height started to change once the second, third, fourth, fifth, and sixth came on, right? All right, what was our M? What was our M in that general equation? Y equals mx plus b. Who remembers what M was? Yeah, they called it your slope, right? But it also means your constant rate of change, your crack, right? So our constant rate of change in this problem was 1.5. Now here's where the equation kind of gets a little weird. It's not till the second one that we start gaining height, right? So if we're looking for height, all right, and we have our constant rate of change of 1.5, this is the part that's different that you're not used to seeing. Why? Because we have to subtract the 1 because the first cup, we didn't gain any height. That's what we started with. Does that make sense? So now watch what happens, and I think your data, if you see these points, right? If I plug a 1 into here, what's 1 minus 1? 0, right? So this is all 0. What are we left with? 8.5. Isn't that the height of the first cup? Now, if I plug a 2 into here, that's our second cup we added on, right? So 2 minus 1 is what? 1. If I multiply 1.5 times 1, that's 1. What's 1.5 plus 8.5? So your constant rate of change is here. Your starting point is here. But this n minus 1, we have to take out this minus 1 because we don't start gaining height on the first cup. It's the second cup. So we have to take that first cup out of the equation so our data matches up. If I just put an n here, basically this becomes our number 1, and that's not correct, right? So we have to subtract that 1 out because it doubles. That's why you don't normally see it. Now I could still put this into this form. This would just take some multiplying, right? We've been solving equations, right? So if I have this, well, this would be fun to see. So n minus 1 plus 8.5. Isn't this just multiplying and combining like terms, right? If I have some number multiplied into this, what would we call that when I try to multiply this through to each term? Who remembers what we call that? Starts with a D, and it's a property. Distributive property. So when you multiply it through, you get 1.5n minus 1.5 plus 8.5. So we could break this equation down into, it would be this. This is 7. Now here's the problem. At 0 cups, did we start at 7 centimeters? No, but technically by the rules of a linear equation, that's kind of how this would go backwards, right? Which doesn't make any sense to the situation. But that would actually be the equation, so if you plug numbers in, it would work. So if you plugged in a 1, you would get 8.5. You plugged in a 2, you get this, 3, and so on, all the way through. So all we did was we took that equation down below here and simplified it. So on the back page, they want us to take this equation we came up with. Now again, yours may be different. The only thing that's going to be the same on everyone's equation is this part right here. Because everyone's measurements did not go up until you added the second cup. The things that are going to be different are here and here, depending on what cup you're using, right? Some of you had 20-ounce cups. Some of you had 8.5-ounce cups. And even with the 8.5-ounce cups, you were within a half of a centimeter of each other, right? We talked about that yesterday, how not everyone's measurements were the same, but they were pretty close. So these are probably the only numbers that are different. But when you go ahead and break it down, your equation, it's still going to become similar to where when you plug values into here now, it's going to work for your table. All right. All right, so if we go to the back page, number 7, they want us to take our equation now from what we got here. So this is kind of our equation that we came up with, and this is just a sample. Remember, not every group is going to have this exact equation because you use different cups. Okay. Now, unfortunately for you guys, we're kind of using your data, so you're kind of getting a freebie. Awesome, right? Awesome for them. Bad for all of you. Unless you've all of a sudden changed your mind and go, we're going to 8.5. Write it down. Right? All my 8.5 groups. All right. So let's flip it over to the back. So now, this was the equation we came up with, right? Once I simplified it. So now if I plug 16 into that, let's see how close our prediction was. Our prediction on the back was 24 for 1, and then, all right, so using their data, all right? So if I plug a 16 into here, 1.5 times 16 plus 7, and that was 24. So we get 31 centimeters. So with the prediction of that 24, we were a little off, right? Just a little bit, right? And all we did was took our number of cups, right, and plugged it into the equation for the n, the number of cups, and this would be the height that we would need the box to be. If we did 50, same thing, but now instead of replacing n with 16, we're replacing n with 50. Well, 1.5 times 50 is 75? Check the math, somebody. I see it's like 12 calculators out. Someone, right? Because half of 50 is 25, and 1 times 50 is 50, so add them together, 75. Mental math. Best calculator you have right here. So add them together, so they had 82 centimeters. So 50 cups is 82 centimeters high just with this data. So if you go ahead and try that with yours, okay, to your equation, see how close your prediction comes. All right, so I'm going to come around and check. I want you to take a few minutes to try to come up with that equation like we did here. I'm going to come around and check each table. And then see how close your actual data comes to your predicted data. And now graph the new line, right? My new line's a little different now because my equation is this. So this 7 in y equals mx plus b form also serves as your y-intercept, right? Which technically means, again, doesn't make sense to the situation, but the graph starts there. What? How can 0 cups be 7 centimeters tall? That's kind of weird, right? So when I go to 1 cup, there's your 8.5. 2 cups is your 10. 3 cups is your, 11.5. So you kind of get the idea. But now this line's going to continue, right? So we'll talk. So as you graph your lines, you'll see a difference between the graph here with our equation that we come up with and the first graph that we did where it was just from points 1 to 5, right? So let's take about 5 minutes. I'm going to come around and check you guys out, and we're going to see how you get your equation. You can see how the data matches up before we give you your homework assignment. So we are going to pause. All right, so to wrap this up, if we went ahead and graph this, right, like we did over here, your predictions probably weren't exact, right? Most of you. But you were probably relatively close. Take a look at, remember your rulers, 7 centimeters, you're not talking a whole lot of distance, right? So if your cups rattle around in the box, I don't know, maybe you got a nice supervisor and he can live with that. How is this graph different from the one we did in number 3, though? Remember, if I'm not mistaken, on number 3, didn't your graph just go from here to, I don't know, like here? It was just a line, right? Jamie? Yeah, there's a y-intercept on your other one, right? Because we started at, 7 or 10 or where some of you started differently. So your line is kind of more complete, right? Right? And it can go on because we can kind of use that line to predict, right? With this line here, this was our actual data, and you only had a set number of data, 1 cup to 5 cups. That was it. I didn't give you an infinite amount of cups for you to just start, measuring height. So your data in number 3 was limited, right? As opposed to now, there's some more differences as well, but you can kind of get the general line of a line segment to our first equation wasn't very complete. It was very focused on from first cup to 5 cup, what's the height? Where this one's kind of, okay, what if you do 16 cups? What if you have 50 cups? What if you have 100 cups? We can use it to gather more information than the original graph. So you do have some homework tonight. We just talked about that, which is right here. So page 16 is number 2. It's A through C, and if you look, it's basically a similar question to this. So you're going to try to graph that data and just answer those 3 questions, okay? And then on page 22 is problem 13. It's at the top. So there's 2 parts to each one, A, B, and C. The first part you have to solve. So again, we've been practicing all week on solving equations, right? So solve for x. And then the second one, you're just going to graph it next to it. Okay? Just give me a basic graph and just, show me the shape of the line. Okay? And then D just asks you to do a little comparison. So 2 questions, probably take you at most a half hour. All right? I know we don't have a lot of class time with this today, but it's not a big assignment. So we will be checking this tomorrow. All right?